Hello everybody, our today's lecture is on linked list, and linked list is a data structure that is made up of nodes like this. So this is called linked list, but before we can make the linked list we need to define each of these individual nodes because linked list is made up of these nodes. So let's see how we can define these nodes. So each of these nodes is made up of two parts. The first part is data. It can be anything. It can be an integer, a float, a double, a string, or it can be a user-defined objects like rectangle, employee, car, or something. The second part is the address that is, in this case, is pointing to the next node. So this part here would contain an address that points to another node. So there are two parts, and we can define in C++ these two parts as a part of a class. Let's say class node, and in here we can define the first part as data. So for simplicity, I'm going to create an integer linked list, a linked list of integer data, and so that means the data type will be int for the data, and the next node, a pointer, that's this one, we're going to name it next, and it is pointing to another node, so that means its data type will be a node pointer. So let's define this class in C++. Class node in data and node pointer nodes. So by default, if we don't define any access specifier here, then both of these variables will be private. So for simplicity, I'm going to make both of them public so we can access them in main function. So now I'm going to create a node in memory. So let's say node pointer and 1 equal to new node. So now what it's going to do in memory, it's going to create a node in memory like this, and it's going to store its address in this variable n1. So this will be the status of the linked list where there is only one node n1 which is currently empty. Now let's put some data in it. So since it's an integer linked list, I'm going to put 1 in the data part, and we can assign that in programming like this. Let's create another node, node pointer and 2 equal to new node, and then assign 2 to its data portion. So in memory it will look like there is another pointer variable n2 which is pointing to a node with data 2 in it. So now we have two nodes, but it's not linked list yet because they are not connected. So ideally we would want here the 1 and 2 and 3 and so on, and this address should point to the next node. So in this case we want this part here to contain address of the second node. Now if you know about dynamic memory allocation, what happens when we initialize any object dynamically and using the new keyword, when we create new node here, then it creates a node and gets that address and assigns it to n1. So that means contents of n1 are actually address that is pointing to this node that was just created. So the same way n2 would contain the address of the second node. So what we want to do is we want to copy the contents of n2 from here to here so that they both are pointing to the second node here. So that way we'll have n1 with data 1 in it, and its next will be pointing to the second node, and so on. So now let's make that connection in programming. So I'm going to move this code up here for readability. So once we have the data in these two nodes, then we can connect these two, n1 dot next equal to n2. So what we did here, we are saying that whatever the contents of n2 are, so in this case that's the address of the second node, put that into n1's next variable. So here, so we copied whatever we had here and we put it in here. So that way we made this connection between 1 and 2. So let's create another node here. So node pointer n3 equal to new node, and then put data 3 in it, so that in memory it looks like this. We're creating another pointer variable n3 which is pointing to a memory location where a node with data 3 is stored. Now if you want to make this connection from here to here, that means we want to set n2.next equal to n3. So we're going to do that in here in the program. So once we make this connection, that means we connected node 2's next to node 3. So now we have a linked list with N1 as the head of the linked list, and the first node, second node, and third node, they are connected. So it looks like this. So now I'm going to simplify this visual to make it actually look like a linked list. So I have redrawn that linked list that we programmed here. So we have N1 pointer variable, which is pointing to node 1. Its next pointer is pointing to node 2, and then second node's next pointer is pointing to node 3. Now we still have these N2 and N3 pointer variables. They are also still pointing to their respective nodes, even though we don't need them, but they are still there in memory. So now if I want to print their data in C++, so I'll do something like this: cout n1.data, a little bit of space, n2.data, and n3.data. And when we run this program, we should see 1, 2, and 3, because those are the 3 data we have in the linked list. So here we have 1, 2, and 3. So this is working. So main feature of linked list is that if you know the starting address of the linked list, you should be able to go from first node to second node and third node. So you don't actually need these individual nodes here, even though we created it here for understanding, but we don't actually need them. So let's remove this need of using N1, N2, and N3 here, and rather just use the next pointer. So I'm going to comment this line out and write it as cout n1.data, and then n1.next.data, so which would point to the second node, and then n1.next.next.data. So it should print exactly the same result as before, because we didn't change anything except that we are not using individual variables now. So let's see, it should still show 1, 2, 3 as before. So here it is, it's still showing 1, 2, 3. So in linked list, we call the first pointer variable as head of the linked list. So I'm going to rename this variable to head, like this. And same way, I'm going to change all the values here and here. So it's still going to print 1, 2, 3 as before. So next step is when we are setting this data individually here, like head.data equal to 1 and 2.data equal to 2 and so on. So rather than setting data like this, we can just create a constructor here that can input as an integer for data, so int x, and then we can set the data inside the constructor itself. So that's going to make our code a little bit efficient. So rather than assigning the data there, we can just put 1, 2, and 3 inside the constructor itself. So if we run the program, it's still gonna execute same way and give us 1, 2, and 3. So next we're gonna make a code a little bit more efficient. So let's see here, we are creating 3 separate nodes: head node, N2, and N3. But essentially what we are saying here on these lines is that make head.next equal to N2. So first we are creating the node right here and then storing this address in N2, and then using the N2 to store that address in head.next. So rather than doing this, we can compress this code into just one line, so we don't have the need of N2 and N3. So rather than assigning N2, I'll just use this part here, new node 2, and put it here. So this will be head.next equal to new node 2, and the same way for node N3, I'm gonna put new node 3 here. So it's the same thing. Earlier the node was getting created here and then its address being stored into N3, and then we are using that address and assigning it to N2, but now we are not doing that. So I'm going to get rid of these 2 lines here. Instead of saying N2, I'm going to say head.next.next. So let's go over this code. What are we doing here in these lines? The first line, we are creating the node head. Here is a pointer variable head, which is pointing to a node with value 1 in it. And then in the line number 13, we are creating another node with data 2 in it right here. And then we are taking this address and storing into head.next. So that means right here. So we are creating the node as well as establishing the relationship in one single statement. The same way, line number 14, we are doing the same thing. We are creating a new node with data 3 in it, and then assigning that address to head.next.next right here. So this way we can keep on creating different nodes. Like if we want to create another node after the node 3, so we can say head.next.next equal to new node with data 4 in it. So it would look like right here that we created a new node and assigned its address to 3's next pointer. So we can keep on creating this node, and if we want to print its data, then we can print it like this. So head.data, head.next.data, then it'll be head.next.next.data, and then we can here with a little bit of space we can say head.next.next.next.data. So if we run it, it should show 1, 2, 3, and 4 right here. 1, 2, 3, and 4. So this is how we create a linked list manually. So obviously this method is not sustainable. We cannot keep on creating new nodes by adding lines here and then keep on printing the data by adding the same lines again and again. It's not very sustainable. After a while we're going to run out of space and it won't work. So how to automate this process, we're going to cover that in our next lecture, but this is for now. Thanks for watching.